receptacle in a house, and this is the voltmeter pin. This is how we can detect voltage. If you stick it inside the hot opening, it's gonna make a noise. What about the other one?
It's like one side, always the hot side.
Yes.
Right.
Which one is that?
The right?
That's small right.
The smaller one.
What do you mean the smaller? So the right is smaller?
Some of them have different sizes, yeah. But not like the ones in the
But like the small side can be on either side.
Yeah, it could be flipped upside down. And sometimes polarity is very important. Some equipment will not accept you to have different polarity. If you look at that, so this plug is not polarized. You can put it any way. However, if you look at this plug over here for this DC charger, you can notice that one leg is bigger than the other.
Is that why sometimes the cord won't go in?
Yeah.
Damn,
Annoying. You're trying to force it in there.
I do
So,
force it.
there's a reason. There's a reason that this is the
I
big
didn't know
side and
that's
small
how
side.
it works.
Yeah, so it's again it goes into in and out.
Wait, so if you put it the other way, it's not gonna fit?
Huh? If you put it the other way, let's just try that. It's not gonna fit. If you're like Jason, you fit it
Bad
in.
annoying.
Yeah, so
So you're not supposed to do that?
no, no.
Like I could mess it all up if I do that?
Yeah,
Yeah, it's like,
especially with charging, when it's a DC charger. Okay, so now you know. So let's look at the sheet and see what you need to do. The first thing is use a voltmeter pin to detect voltage from an outlet, which is here. You can go with this
So
one.
that won't shock you? if you
No.
just put it in?
It's plastic. Just what is it measuring?
You could put anything plastic in the outlet and it won't shock you?
No, it's plastic. What is this? How is this working? It's plastic. What is it measuring?
The volt.
How? Magnetic field. So this one is not even touching. Look, it's not even touching. But it will tell you if there's voltage or not. So it's measuring the small voltage inside the socket. So this is how we measure the voltage. Measure the amount of voltage. The amount of voltage. So you're gonna go into the multimeter.
so wait, first one, should we just write like the smaller side?
Well, you're gonna go and do it yourself. So I'm gonna turn this multimeter on voltage. What do you think this is, AC or DC?
DC.
Who thinks DC and why? It's not DC. It's the AC. All electricity in your house receptacles are alternating current. So I put it in volts AC, and I will measure using. Where would I put these? Hot and neutral.
Yeah.
I should get 118. What if it's the other way? What if I put neutral and on ground?
It's not gonna give you the right.
Nothing. What if I put it neutral and hot?
It's not gonna.
Now,
It's gonna take air.
what about hot and ground?
Nothing.
Should get a measurement.
Yeah, it should give you something.
Give me nothing, but this is not grounded. But ground and neutral, ground and hot should give you the measurement. Okay? So this is how you measure voltage. I want to measure voltage. How do you measure frequency? This multimeter has frequency, and if you see the frequency is in hertz, so you turn it into hertz, and again you stick it in there. What do I get?
60.
Almost 60 hertz. So you got that. It's turned up by itself. So this is how you do measure the amount of voltage. You measure the frequency. Use a clamp-on meter. Measure the amperage draw from running equipment. I'm going to use this as my running equipment to show you the voltage. So if I look in here, the amperage designated for this motor is around 1.5. If you look here, it will tell you amps, 1.8 amps. This is how much it's supposed to draw. This is the motor. So I'm going to plug in the motor and using clamp-on meter. Cover this. And probably something you might have to do in the field. Get it going. Just connect the motor by itself and try to measure the amperage. Why do I need to measure the amperage? To know if it's actually working or not. It says 1.8. I expect something around 1.8. So I'm going to use the clamp-on meter, and I'm going to put it in. I have ranges. I have 2 amps, 20 amps, 100 amp. Which one I'm gonna put it on? I'm expecting 1.8. Huh? I'm expecting 1.8 amps. So I have 2, 20 and 100. Two.
Oh, I thought you said 20 and 100.
And is it AC or DC? Thank you. So we're gonna plug this in. Turn it on. And I got 1.4.
Why did you do that wire?
Doesn't matter.
So 1.4 is fine.
What if I put it in both again? Yeah, it's zero. So why do you think it's 1.4 even though it says 1.8?
Because they ain't connected to nothing.
Thank you. Because it's not doing the work it's supposed to do. Once you put the pump in here, it's gonna draw more amps. So more amps, more work. You get that? So what if it's drawing 3 amps? Something is wrong. It's stuck. It's grinding against something. It's gonna overheat and eventually it will break. So now we know how to do amperage. Get an equipment, motor, light bulb, and measure the resistance. So I'm gonna measure the resistance of this transformer here. I wanna see what is the resistance. I'm supposed to be getting something around like high resistance from this winding. So where do I put it? Yeah. Resistance. Put it in 2 sides. Should be getting 18,000 ohms. And that's 18.3 kilo ohms. Good? Now I want you to do it. Just watch me. You can do it yourself. Then measure the capacity of a capacitor. It's a capacitor, right? So what do I use for the capacitor? There's a symbol here for a capacitor. This one. So
Should we know the labels, like what they look like?
yeah. That's something you want to do. So this one says here, if I look at it, it says 17.5 microfarad. MF. I'm gonna try and see what do I get out of this. 17.8. It's pretty close. And look at the symbol. What does it say? So a little squiggly line. That's microfarad.
Does it matter where you put the leads on that?
No, it doesn't matter. Good question. Let's try. Experimentation. Same thing. Okay? So measure your body heat using multimeter. So if you bought this Fluke multimeter, it has a temperature measure in it. You're gonna change the leads.
You should measure it, right?
You said body heat?
Yeah.
You could do that?
So I'm gonna plug in this in here, put it on temperature, and hold your finger. You give it the outside body heat, so it's gonna be around 87
Oh, that's like the weird. What is that called?
thermocouple. Yeah. That's your body temperature from the outside. If they want to take your temperature on the inside, they use the ear thing or the tongue under the tongue. But now your body is expressing heat. So this is how you measure temperature. Measure the voltage of a DC transformer. So we said all batteries are AC or DC? Lance, batteries are DC or AC?
Took the words right out of my mouth.
Okay. I'm Latino. So I'm gonna turn this on. Is it on? It is on. I'm gonna put the leads on voltage AC, which is the line. This also measures the voltage. So I'm gonna go and measure the voltage on DC. And I'm getting negative, which is okay because it's a polarity thing. To change the polarity, you get positive the same number. So 0.5.
It's ever
You could put
negative,
them on
you
ten.
can
Oh,
switch
so
them.
if
Yeah.
it's negative, if you just switch them, it
Yeah,
goes
you
Yeah.
switch them.
Yeah. Why is it? Because it's one direction. This is the battery. You can also measure the battery's voltage. 20 volts. And if you see it, the battery has plus or minus. So if I put this in the minus and put this here, it should give me positive 20 volts. So this is 20 volts, and I charge it with 3 volts with the high average.
So the volts would stay the same even if it's negative or positive? They're both
Yeah.
the same?
But it has to be the right direction. If you put the battery in the wrong direction, the things will not work.
Just like how you put in a remote.
Yeah. Use the switchboard. The switchboard is over there. I'm gonna have the manual try to rig one of the switches and we can test the connectivity. A contactor. This is a contactor. It's one of the things that we always work with, and we want to test this contactor for continuity. Make sure it works or not, because it's supposed to connect two terminals. So what I'm gonna do, continuity.
That's just a decent relay. That's just a relay. The
Yeah.
can handle more.
Yeah.
Alright.
I'm glad you remember.
Yeah, I've always wondered what the difference between those were.
See, you put them at two ends, and this one works. This one is connecting. This is something you will have to do in the field.
So that's working without even being plugged in or anything?
Yeah. It's connecting, just connecting. I'm just testing the connection. And this is normally open, so you can close supposedly. No? Okay, fine.
No, not myself.
So you get the idea. And now I'll show you how to test the continuity on the board. So to test resistance to continuity, come over here. You will need to, when you test for resistance or continuity, it's check it on or off.
What?
If you want to test for resistance, it will be on or off. Off, so it's off. I'm gonna test for continuity here. I have no continuity. What about this one? This is off. So something is off. When you turn the switches on. Turn the switch on. And you turn it on.
I think you need to have the whole plug.
Say what? So it's on, on. Okay, what if I want this the entire circuit from start to finish? And this is a complete circuit all the way from here. This is how you keep measuring continuity. So this means that to the entire circuit I have continuous circuit. And this is how you test for continuity. Again, how you test the wire. Let's say this wire is like hundreds of feet. One end to one end. Yeah.
How was the meter able to give you the numbers and stuff even if there's no current going through the?
Good question. When we talk about multimeters, what do ohmmeter have different than voltmeter and ammeter? This ring is battery operated, so it has a 9-volt battery. So the 9-volt battery is sending smaller amperage to the wire, 9 inverter. With no battery, you'll never be able to test resistance. Okay.
So, the battery is down, would that affect it?
Yeah, depending on what. Okay, here's a situation that is very practical. You have a thermostat on the third floor. The thermostat is connected all the way down to the basement. You control. A mouse came and chewed the wire. How do you know if the wire is bad or good? How?
Test that.
But it's not connected at the bottom. So one of the.
But wouldn't it tell you? It wouldn't
Yeah,
send you nothing at the top, right?
So this is my thermostat here. I'm running different thermostat. This is screwed in the middle. But you can do it here. It's going to be not continuous. So how do I know it's the wire, it's the switch, it's the thermostat? To make sure it's the wire, you unplug this from the boiler and control. Yeah. Twist them at the end, so you have control loop, complete loop. Then you test for continuity.
So that way you know.
No, at least the wire is intact. If there's no continuity, the wire is faulty throughout the house, so you have to pull the wire and put on a new one. So this is an easy way to know.
So you just twist the wire at the end, and
That's
that's
how you
what.
see if the wire's shot or not?
Yeah, that's the one way.
So you would be in the basement and you unplug it from the boiler, and then you just twist it.
Yeah, and you go upstairs and take that thermostat and look, check the wire.
Well, what if the wire's bit through? That doesn't.
That doesn't mean the wire is bad, so you're gonna have to take the wire out and change it. because you wouldn't know where, but you know at least the wire it's not continuous. Yeah. Okay. So you see how it's done now?